So the problem is about the convergence divergence of the following series, sigma of 1 over n ln natural log of n squared, and we cannot take n equal 1 because ln of 1 is 0, so we're going to start at 2. So this is what's known as Bertrand series. Okay, so for this one, if we use the root test or the ratio test, we're going to find the limit equal to 1, so they are unconclusive. So here the only way we can do this one, this specific one, is to use the integral test. So what we're going to do, we're going to introduce the function f of x equal 1 over n ln of n, x. 1 over x ln of x squared. Clearly, x ln of x is increasing, therefore 1 over x ln of x squared is decreasing. So this is not hard to see, is decreasing. Okay, for x between 2 and infinity, for x greater or equal than 2, and it is positive as well, so f of x is greater or equal than 0. So now we know from the integral test that the improper integral f of x dx is convergent if and only if the series f of n from 1 to infinity is convergent. So this is the integral test. This is by the integral test. So now let us pay attention to the improper integral. Okay, so we have 2 to plus infinity 1 over x ln of x squared dx is equal, the only bad point is infinity, limit when a goes to plus infinity 2 to a 1 over x ln of x squared dx. So now we have to pay attention to the proper integral, okay, to see if we are able to integrate. So we are looking at the untitled derivative of 1 over x ln of x squared dx. And for that we're going to use the substitution u equals ln of x. So we know that du is going to be 1 over x dx. Therefore this integral is the integral of du over u squared. Okay, for which the integral, now we use the fundamental formula, the integral of u to the power of alpha, the integral is u to the power alpha plus 1 over alpha plus 1. So this will be minus 1 over ln of x plus c. So the integral from 2 to infinity of 1 over x ln of x squared dx equal limit when a goes to plus infinity of the integral from 2 to a x ln of x squared dx. And since we know how to integrate, so this is limit when a goes to plus infinity minus 1 over ln of x between 2 and a, which gives us limit when a goes to plus infinity of minus 1 over ln of a minus minus plus 1 over ln of 2. So when a goes to infinity, okay, when a goes to infinity, ln of a will go to ln of plus infinity, which is plus infinity, and 1 over plus infinity is 0. So the integral is, the limit of this is 0 plus 1 over ln of 2, which is 1 over ln of 2. Therefore, this improper integral, 2 plus infinity 1 over x ln of x squared dx, is convergent. And by the integral test, we know now that sigma 1 over n, natural log of n squared, is convergent by the integral test.